to the next speaker. And this is Fredrik Bergström from FMT Mark. And he's going to, I believe, show us a little bit of how modern technology can help us in our conservation of dry stone walls and how to document them. So Ted, if you could stop screen sharing.
Let's see.
It's a red button, I think, in the top there.
There, thank you.
Yes, tackar. So Fredrik, feel free to present yourself a little bit more, what you do, and I'll hand over to you.
Thank you. I'm trying to share my screen here. So let's see if I can take the correct one, maybe.
Ted, you can turn out your video off, please.
Is this one the correct one? You think?
That looks great. Thank you.
But it don't want to. How do I step further on? It just.
Do you the arrows on your keyboard? Do they work?
Nope.
Left and right arrows? No. Could be left and right mouse button could also work sometimes.
Okay, let's try that one. Or am I? Strange.
Yeah, there's. Okay. Try the arrows now. I think maybe you just hadn't sort of.
Yeah. Here it is.
Good.
Okay. Then I will just want to have this one here on the screen. So now, okay. So I think I'm good now. Thank you, and hi everybody. I'm feeling a little bit misplaced here, and that's because it's really good listening to all of you, because you are such experts on dry stone walls and all these crafts that are not in use so much today. As Joachim said, that we are missing a lot of this knowledge today, and I'm seeing that too. My name is Fredrik, and okay, now it don't want to. It was down and up, not.
Oh.
My name is that's why. My name is Fredrik, and I'm a 46-year-old contractor. So I'm just an ordinary contractor from start. I have not been working with dry stone walls for my whole life, but of course it has been a part of my project sometimes, and I'm really impressed in old construction. And as the text here says, that I have an unhealthy technology interest. And I think that's why I'm here today, to talk about how we can use the new technology to help us develop and restore old things. We need all of this knowledge or this for building these dry stone walls, but we can have the technology help us. The technology can't build them for us, but they can help us. So this is just a presentation of some technology that we are using in our project. I just took two easy projects, a dry stone wall at a Swedish church, and Göta Kanal, which is a channel which runs through the whole Sweden, straight through Sweden. That's because we have done a lot of work with the channel company for looking at the walls and the locks the whole way. Göta Kanal is a 190-kilometer long channel, and I think it was finished 1832. They have dug it about 87 kilometers and blasted it. So it has 58 locks on the way, and our job the past 5 years has been scanning those locks for looking for movement in this wall. This is not dry stone walls the whole way, but kind of. So that's why I have this as an example. So why do we do this? Why do we use technology to document our dry stone walls, or any construction for that case? It could be castles, inside, outside, whatever, roofs. We do this to predict trouble, and this is an example of one of the locks in Göta Canal. And as you can see on the right side, you have a color scheme, and on the right side you have a table with some numbers on it. All numbers are control points, which is on the wall, and the colors is showing movement of these stones from one measurement to another day, one measurement to another. And as you can see, the color scheme shows that we have zero movement is green, and over 50 millimeters is red. And a negative value is if it's leaning away from us, which will not happen here. Of course, if they are moving, they will move in. So we don't want to see yellow or red. And but as we can see, sorry, it's the other way around, of course. Negative is against this, and positive is away from me. And the reason I'm showing just this picture is that you can see that we have a blue spot, and that is just one stone. And this stone had moved almost 30 millimeters. So in this case, we could see that, okay, something has happened. We could call the guys who is responsible, and they could check the stone and why this one has moved. So this is an easy way to predict troubles which can come later on. And as Joachim said earlier today, that the biggest problem we have is water, and water causes stuff to move, especially retaining walls. And if we are doing measurements in the spring or in the autumn, the walls can be moving, but we are looking for movement that are increasing, not going back and forth. So that's why we are doing 2 measurements a year, and we have been doing so for about 5 years now. And another cause of using modern technology is that we can get some help with rebuilds. So if we're doing rebuilds of a wall and we want it to look the exact same way as it did, we can use modern technology to document it and then make some easy drawings. We can do easy measurements and check angles, anything, and it's really, really easy. We can do this manually, of course, but it's a really simple way and a nice way, and a really exact, precise way to document and show. So what kind of technology do we use? We are using, for documentation, we are using scanners. That's one of the instruments that you can use for doing the documentation. And you have today, the technology is so good today, and it's quite cheap also to buy. Everything is of course depending on stuff, but today you get really, really good equipment for not so much money. So you can use scanners with the possibility to take photos, and you get millimeter precise measurement data. You can also use these scanners to georeference the data, and otherwise you can use georeference data to put it in the right correct place on Earth. You can put it on maps, or you can also use older maps to fit to the new maps and do predictions of what can be in the way if you're doing excavations and stuff like that. As you can see, here is some retaining walls on the pictures here, which we have the church wall and the lock. One other really good way to collect data is photogrammetry. The only thing you need is a good camera, really, and then you need software for photogrammetry. And that can also be done, the calculations, it can also be done online with really good software, so you don't have to use your own computer to do this. You can do it with drones to make photogrammetry for large areas or high retaining walls. If you are flying close with really good cameras, you get a really millimeter precise 3D model of the object you are photographing. And here is just an example where we made to get the volume of a stone. We had a project where we were going to tell exactly what the volume were of this stone. And as you can see, the data is so good today that you can do almost anything. You can look for cracks or everything just looking at data. And the good thing with this is that you can do this without going to the place. We are doing a lot of projects where we are just collecting data, and then we are working with clients who are far away, or just send them data and they can look at the 3D model. So you don't have to be on site. You can, of course, use ordinary survey equipment, and that's just with a total station. You can do some direct measuring with a prism. This is also, of course, millimeter accuracy. If you're measuring the top of a wall or something like that, you can measure with the direct measuring. You can measure the edge of stones and stuff like that. Places you can't reach, you can just measure them with a laser pinpointer. And this is one of the things that we are working a lot with in my company. We are using machine control systems, and that is that we have GPS systems mounted on all machines, or on we have 6 excavators, and they all have GPS systems, and they measure it's really precise. It's about 10 to 20 millimeters on the corner of the bucket, and that gives us a possibility for the driver of the excavator to make measurements on site when we are not there. So he can do measurements with the machines and just upload it, and we can download the data and use it in the office. So that's 4 ways of collecting data for documentation of any construction, walls or garden of edges, anything. And if we are talking some kind of future here, this is not future, but close to. There are not so much contractor or entrepreneurs which is using the technology which you can use today. They're not using it. but we are. So this is kind of the future. It's not the future for us, but it's the future for a lot of other entrepreneurs. So we are using virtual reality, Oculus Quest in this case, and in the virtual reality, we are doing 3D modeling. So you can have a dry stone wall, you can have the stones by themselves in 3D model, and you can take the wall apart and mount it back together. And you can do this, I can do this being in my office here, and I can have a client in Dubai or anywhere in the world, which is also using his Oculus Quest at his office, and we can do this together. So it's really easy to work on a project together and ask questions. The most important thing, of course, when you're doing this is to be on site and doing this the old way, because that's where you get the final result. But this is a great tool on the journey, on the way to make things easier. We are also using augmented reality. If you're looking at the video here, you can see that the solar panels are on site in the down video, but they are just a 3D model. And in the top video, they are mounted in real life. So we are taking augmented reality to show such a thing that houses, retaining walls, bushes, anything you can imagine, we are putting them live on site. So you can just walk around with an iPhone with the GPS mounted on it, as you see on the picture, and you can see 3D models on the place, on the exact spot with the accuracy of about 10 millimeters. So this is also a really, really good tool using for presentation on site. And this is, of course, not the real thing, but it's a way of showing things that makes you, it gets you talking about the same thing. You don't, if you're talking about a retaining wall, two people, and it's someone who does not have that knowledge, they will talk about, you will talk about the same thing, but the picture in your head are different. And this is one way to make that be the same picture. And we are also using this augmented reality with a QR code. So we are placing the QR codes on our site maps, the drawings. For example, as you can see in the left picture here, there's a A1 drawing, and we can read the QR code with the phone, and the 3D model pops up and is in color above the drawing on the right spot on the drawing, but it's a 3D model. So then the client can walk around and look at the phone and see anything in which scale we have placed it, 1 to 100, 1 to 200, anything, even 1 to 1. As you see in the right picture, we are placing a QR code on a site, which is going to be a new home for a family, and they can read the QR code on site, and the house will be placed in their phone. So that's also one of the technologies to use in construction and for presentation. And of course, we are using machine control systems. So in the left picture here, as you can see, that's not a picture of the house and the garden, that's a scan data. And the stair and the wall, which is not the dry stone wall, I'm sorry for that, is a model, 3D model wall and the stair, which is an IFC file. The exact same file is placed in the machine, which is a small excavator, and they can use, the operator of the machine can see exactly where the wall is, where the stones are placed, and the height. So that makes his job much easier when doing his job, and it's much faster, of course, and it gets right. So he's know what he's doing all of the time. Okay, thank you for listening. I don't know how the time is here, but I
think you ended perfectly. Thank you.